Section 11.3, Solutions of Equations, Reducible to Quadratic Form, and Applications. So in this section, we will be solving equations in quadratic form. So let me do on page 478. Problem number 2. X cubed minus 16x equals 0. In exercises 1 through 20, solve the equation by factoring. So I notice that there's an x in common, so let's factor out an x. What's inside the parentheses is just the difference of squares. So by the special product formula, I have that that this is the product of the sum and difference of two terms, x minus 4, x plus 4. So now I've written this in as a product of a whole bunch of terms. And so I can set each factor equal to 0 and solve for x. So x is 0. Add 4 to both sides of your equation. Subtract 4 from both sides of your equation. X equals 4. X equals negative 4. So I notice that this is a cubic and I get 3 solutions. Let me do problem number 10. Z to the 4 plus 9z cubed plus 14z squared equals 0. So let me factor out what's in common. Z squared from every term. So z squared times z squared plus 9z plus 14 equals 0. Let's try to factor what's in the parentheses. And so this is a monic quadratic. Let me bring down the plus. Positive times positive is positive. I want two whole numbers whose product is 14 and whose sum is 9, 7, and 2. Set each factor to 0 and solve for z. Oops. So I get z equals 0. Subtract 7. So I get z equals negative 7. Subtract 2. And I get z equals negative 2. Since I had that z squared was 0, this is actually what is called a double root. It's really z equals 0, z equals 0, z equals negative 7, z equals negative 2. So there's really 1, 2, 3, 4 roots. And this is a fourth degree equation. And so I found all 4 roots. Let me do problem number 20. And so z to the fourth. Okay, so in this case, actually I can't factor out anything in common. but this is quadratic in form. And so if I look at this, well, this is actually quadratic in x squared. And so this looks like x squared squared minus 10x squared plus 9. So it really looks like a polynomial that's quadratic in x squared. And so I can actually see if I can factor this. So this is actually, let's bring down the x squared. Minus times plus is minus. So I want two whole numbers whose product is 9 and whose sum is 10, 9 and 1. But each of these are perfect, are difference of squares. So I can use my special product formula to factor each of these. So this factors into x minus 3, x plus 3, the product of the sum and difference of two terms. And this factors into x minus 1, x plus 1. I can set each of these factors equal to 0 and solve for x. I can add 3 to both sides of my equation, subtract 3, add 1, subtract 1 from both sides of my equation. And so I get x equals 3, x equal negative 3, x equals 1, x equals negative 1. And so I notice that there are 1, 2, 3, 4 solutions for this fourth degree equation. So I found all the solutions. Let me do problem number 22. In exercises 21 through 40, solve the equation by using an appropriate substitution. And so x plus 3 squared minus 5, x plus 3 plus 6 equals 0. Okay, so this just looks like a squared minus 5a plus 6. So I can factor this. This is just a monic polynomial, and it's a matter of fact, it's a monic quadratic in the variable x plus 3. And so I can factor this. X plus 3, bring down the minus, x plus 3, negative times positive is negative. I want two whole numbers whose product is 6 and whose sum is 5, 3, and 2. Let's simplify this. So let me get rid of the parentheses. X plus 3 minus 3, x plus 3 minus 2 equals 0. Let me simplify what's in the parentheses. And so the 3's cancel, so I just get x. 3 minus 2 is 1, so get x plus 1 is 0. Set each factor to 0. X equals 0. X plus 1 equals 0. Subtract 1 from both sides of my equation. And so I get x equal negative 1. So I have two solutions. X equals 0, x equal negative 1 for my quadratic. Okay. Let me do problem number 24. Three x plus 1 squared, 7, 3x plus 1 plus 10 equals 0. So again, I can factor this. This is quadratic in the variable 3x plus 1, and it's monic. So let me, in the variable 3x plus 1, bring down the plus times plus is plus. I want two whole numbers whose product is 10, whose sum is 7, 5, and 2. Let me simplify this. So let me get rid of the parentheses. And so I get 3x plus 6, 3x plus 3. I could actually factor out, oh, maybe I should, just so that you sort of see this. So I can factor out a 3 from the 3x plus 6. So I get 3 on the outside times x plus 2. I can factor out also a 3 from the 3x plus 3 to get, well, 3 times 3 is 9, x plus 1. And then I can set each factor to 0 and solve for x. Subtract 2, subtract 1. So x is equal to negative 2, x is equal to negative 1. I actually did not need to factor out the 3 from each of these factors. I could have done it by just solving 3x plus 6 equals 0, 3x plus 3x plus 3 equals 0, and I would have gotten the same answer. But I wanted to show you how to factor out 3's from each of these factors. Let me do problem number 28. X to the 4 minus 81 equals 0. Okay. So let me solve that. So this is the difference of squares. X squared minus 9 times x squared plus 9 equals 0. I can factor x squared minus 9. That factors into x minus 3, x plus 3. I could factor the x squared plus 9 over the complex numbers. But maybe I'll just leave it so that I can use the quadratic formula to solve that. So I mean, I could factor it if I wanted to as x plus 3i times x minus 3i, but I'll leave it as x squared plus 9. Set each factor to 0 and solve for x. So using the quadratic formula, I'll get the same answer. So it's sort of a good practice to do that. So let me add 3. So I get x equal 3. Subtract 3, so x equal negative 3. Let's use the quadratic formula. X equal negative b plus or minus the square root of b squared minus 4ac all over 2a. And so I get x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So I get x is equal to 0 plus or minus 0 minus 36 is negative 36 over 2, which is equal to 6i over 2. So x is equal to plus or minus 6 divided by 2 is 3i. But, well, actually, no buts about it. That's fine. So So in this case, I have 1, 2, 3, 4 solutions to my fourth degree equation. Let me do problem number 32. Three t squared minus 1 square, 6, 3t squared minus 1 plus 8 equals 0. And so, again, this is quadratic in form. It's quadratic in the variable 3t squared minus 1. And so I can factor this as 3t squared minus 1. Bring down the minus. 3 3t squared minus 1. Minus times plus is minus. I want two whole numbers whose product is 8 and whose sum is 6. So 4 and 2. And so I get, forgot the exponent, so I get 3t squared minus 1 minus 4, removing the parentheses. 3t squared minus 1 minus 2, again removing the parentheses. Combine like terms, so I get 3t squared minus 5. 3t squared minus 3 equals 0. Again, I could factor out the 3, but since I already factored out the 3 above, I think in, what was that, problem 24, I'm not going to do it in this one, so I'll show you a different way. I just won't, I'll just leave it unsimplified. So set each factor to 0, and you'll see you still get the correct answer. And so set each factor to 0 and solve. Add 5, 3 to both sides of your equation. So you get 3t squared equals 5. 3t squared equals 3. Divide by 3. So you get t squared equals 5/3. T squared equals 1. So by the square root property, t is equal to plus or minus the square root of 5/3. There's two solutions. T is equal to plus or minus square root of 1, which is 1. Here's another additional two solutions. And so I have 1, 2, 3, 4 solutions. 2 times 2 is 4. So to this fourth degree polynomial, I have 4 solutions. So good, I found all solutions. Let me do problem 34. And so this is, well, I'm actually, maybe I'll do this two different ways. So let me solve this, but let me solve it two completely different ways, just so that you'll see that this is actually something we've done before, but it looked different. Okay, so 3x plus 8 radical x plus 4 equals 0. So notice that this is quadratic in the square root of x. So this is quadratic in radical x. So I can actually factor this as 3 radical x times radical x plus 2 plus 2. And let's see if this, I factor it correctly. 3 radical x times radical x is 3x. 3 radical x times 2 is 6 radical x. 2 times radical x is 2 radical x. So 2 rad x plus 6 rad x is 8 rad x. 2 times 2 is 4. So it factored it correctly. Set each factor equal to 0. and solve for x. Subtract 2 from both sides of my equation. So I get 3, oops, 3 rad x equals negative 2. Rad x equal negative 2. Square both sides of your equation to get rid of the square root. And so you get 9x equals 4. X equals 4. Divide by 9. So you get x equals 4 over 9. But now, since you're solving a radical equation, then I have to check. And so remember, you always have to check radical equations. So let's check if each of these are correct. So let's check x equals 4 over 9 in the original equation. And so is 3x plus 8 radical x plus 4 equal to 0. The 3's cancel, so you get 4/3. The square root of 4 is 2. The square root of 9 is 3. Plus 4, is that equal to 1? Well, let's write those over 1, multiply by 3 to get a common denominator. And so is 4/3 plus 16/3 plus 12/3 equal to 0? No, certainly not. That's going to be 32 over 3, and that's not 0. So no. Oops, let me do that in red. So no, that's not a solution. That's an extraneous solution. But notice that if I would have changed this positive 16 over 3 to negative 16 over 3, I would have gotten 0. Okay, so that's good. Let me check at x equals 4. Let's see if that works. Is 3x plus 8 radical x plus 4 equal to 0? I don't know. Let's check. And so is 12 plus 8 times 2 plus 4 equal to 0? Is 12 plus 16 plus 4 equal to 0? Is 32 equal to 0? Again, no. But if I would have changed this positive 16 to a negative 16, then it would have worked. And so, no, that's not a solution. So therefore, there's no solution. And so, let's do this. So note, actually, I have here 3x plus 8 radical x plus 4 equals 0. Actually, this is the same as what we've done back in, I guess, like 1 or 2 chapters ago when we looked at radical equations uh, in that chapter dealing with radicals. And so let's subtract 3x, 4 from both sides of my equation in order to isolate the radical on one side of my equation. And so 8 radical x equals negative 3x minus 4. So let's check if, so I've isolated radical x on one side of my equation. So let's square both sides of my equation to get rid of the square root. So that says 64x is equal to 9x squared net minus 3x times negative 4 times 2 is 24x. Negative 4 squared is 16. Let's subtract 64 from both sides of my equation. And so I get 9x squared minus 40x plus 16 equals 0. Okay. So, let's see, that's let's try to do this. So I get here 9x squared minus 36x minus 4x is minus 40x plus 16 equals 0. Set each factor to 0. Solve for x. Add 4 to both sides of my equation. So I get 9x, equals 4. X equals 4. Divide by 9. So I get x equal 9 over 4. But again, well, you could check at 4 over 9. Oops, I wrote it as 9 over 4. You could check at 4 over 9. And we already saw that the original equation doesn't work. Or you could check at 4, and again, at 4 it doesn't work. So check. At x equals 4. And then you get 32 not equal 0. And again, you check at x equals 4 over 9. But then again, you get 32 over 3, which is not 0. So with that, you get contradictions. And so the answer is no solution. Just like before. Okay, so from the previous chapter, that was the technique that we had. But I think actually the technique in this chapter is a little easier. It depends on what you think. You could have also used quadratic formula, by the way, obviously if you can't factor. Let me do problem number 36. X minus 3 squared minus 2x minus 4 equals 0. So in this case, actually, I am going to use a substitution for this one. So let t equal x minus 3, which means that x equals t plus 3. And so I get here x minus 3 is just t. And x is just t plus 3. And so in terms of the new variable, I get the following equation. Now let me multiply the negative 2 inside the parentheses. So I get t squared minus 2t minus 6 minus 4 equals 0. And so I get t squared minus 2t minus 10 equals 0. You can try to factor that, but I guess you really can't factor that. So let's use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And so I get t is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So t is equal to 2 plus or minus the square root of negative 2 squared is 4. Negative 4 times 1 times negative 4 is plus 40 divided by 2. So this is equal to 2 plus or minus 4 plus 40 is 44 divided by 2. Now I can rewrite 44 as a product of two factors, one of which is the largest perfect square factor of 44. And so let's write this as t is equal to 2 plus or minus the square root of 4 times 11 over 2. The square root of 4 is 2. So let's factor out the 2. So what remains after I factor out the 2 is 1 plus or minus radical 11 over 2. Now the 2's cancel. And so I get that this is equal to 1 plus or minus radical 11. And that is your answer. And so I've solved the above equation. Let me do problem number 40. X squared plus x minus 2 squared minus 4 x squared plus x plus 11 equals 0. So in this case, I don't know, let's see what I called it before, t equal x squared plus x minus 2. So that means that if I add 2 to both sides of my equation, I get that t plus 2 equal x squared plus x. And so x squared plus x minus 2 is just t. X squared plus x is just t plus 2. And so now in terms of the new variable, I have that equation. Let me multiply the negative 4 inside the parentheses. And so I get t squared minus 4t minus 8 plus 11 equals 0. Combining like terms, I get t squared minus 4t minus plus 3 equals 0. And so I can factor t minus, bring down the minus. This is a monic polynomial. a monoquadratic. So it factors as, well, bring down the minus times plus is minus. I want to find two whole numbers whose product is 3 and whose sum is 4. 3 and 1. Set each factor equal to 0 and solve for t. So t minus 3 is 0, or t minus 1 is 0. Notice that t is x squared plus x minus 2, and x squared plus x minus 2. And so I have x squared plus x minus 5 is 0. X squared plus x minus 3 is 0. Let's solve this using the quadratic formula. And so I have x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. And so x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, all over 2a, or, here, let me move this so I have more room. Actually, let me move both of these. So I have a negative b plus or minus the square root of b squared minus 4ac all over 2a. So x is equal to negative b plus or minus the square root of 1 plus 20 over 2. So x is equal to negative 1 plus or minus the square root of 1 plus 12 over 2. So x is equal to a negative 1 plus or minus the square root of 21 over 2. That gives me two solutions. X is equal to negative 1 plus or minus the square root of 13. Gives me an additional two solutions. So I have 4 solutions in total. And so this was a fourth degree equation. And so I found all 4 solutions. So that's 40. Let me do problem number 42. X squared minus 16 over x minus 4 equals 0. In exercises 41 through 60, solve the equation by any method. So let's factor x squared minus 16 as x minus 4 times x plus 4. Notice that I can cancel these. So I get x plus 4 is 0. Subtract 4 from both sides of my equation. So x equals negative 4. Notice I'm not dividing by 0, so x equaling negative 4 is my solution. Let me do problem number 48. 3 over 4x minus 1 equals 2 over 2x minus 3. Let me cross multiply. So I get 3 times 2x minus 3 equals 2 times 4x minus 1. Let me multiply the 3 inside the parentheses, 2 inside the parentheses. And so I get 6x minus 9 equals 8x minus 2. Subtract 6x, add 2 to both sides of my equation. And so 2x is equal to negative 7, divide by 2. So x is equal to negative 7 over 2. And that is my solution. Notice I'm not dividing by 0. If I plug in negative 7 over 2, I'm not dividing by 0 here, nor am I dividing by 0 here. And so that's my solution. Let me do problem number 56. X squared minus 1 over x squared equals 2. Let me solve that. I guess let me get rid of the denominator. So let me multiply both sides of my equation by x squared. And so I get x to the 4 minus 1 equals 2x squared. Let me subtract 2x squared from both sides of my equation. So I get x to the 4 minus 2x squared minus 1 equals 0. And so let me use the quadratic formula. This is quadratic in x squared, so my variable from which this of which this equation is quadratic is x squared. So x squared equal negative b plus or minus the square root of b squared minus 4ac all over 2a. And so x squared equal negative b plus or minus the square root of b squared minus 4ac all over 2a. So x squared equal 2 plus or minus the square root. Negative 2 squared is 4. Negative 4 times 1 times negative 4 is positive 4 all over 2. And so 4 plus 4 is 8. I can write 8 as the product of 4 and 2. 4 being a perfect square factor, the largest perfect square factor of 8. The square root of 4 is 2. There's a common factor of 2 in the numerator. And so I can write x as 2, 1 plus or minus rad 2, x squared over 2. The 2's cancel. And so I get 1 plus or minus rad 2. And so that's x squared. Therefore, x is equal to positive or negative 1 plus or minus rad 2 and positive. So it's equal to negative 1 plus or minus rad 2 or positive 1 plus or minus rad 2. So you could actually write it as, well, you could put the minus inside, but I'll just leave it this way. Let me do problem number 59. X squared minus 3 minus 5 over x squared plus 1 equals 0. So let me get rid of the common denominator. So let me multiply both sides of my equation. Let me multiply both sides of my equation by x squared plus 1. And so let me multiply the x squared inside the x squared plus 1 times each of these. So I get x squared times x squared is x to the fourth. Then I get here 1x squared minus 3x squared is minus 2x squared minus 3 minus, well, the x squared plus 1's cancel, so you get minus 5 equals 0. So I have here x to the fourth plus x squared minus 3x squared is a negative 2x squared minus 3. Combine like terms, so I get x to the fourth minus 2x squared minus 8 equals 0. Let's try to factor this. Bring down the minus. Times minus is plus. I want two whole numbers whose product is 8 and whose difference is 2, 4, and 2. And so I get here oh, maybe I'll just set each factor to 0 in this case and solve for x. Add 4, subtract 2. And so x squared equals 4, x squared equals negative 2. And so I have, by the square root property, x is equal to plus or minus the square root of 4, 2. By the square root property, x is equal to plus or minus the square root of negative 2, which is, well, I rad 2. Notice that when x is equal to 2, I'm not dividing by 0. X is equal to negative 2, I'm not dividing by 0. X equal I rad 2, I'm not dividing by 0. X equal negative I rad 2, I'm not dividing by 0. So I'm never dividing by 0. Therefore, I have these 4 solutions to this fourth degree equation, 2 of which are complex. Let me do problem number 64. Find 2 consecutive positive odd integers whose sum of squares is 130. So let x be the first positive odd integer. Let x plus 2 be the next positive odd integer. The sum of their squares is 130. Let's solve this equation. So we get x squared plus 4x plus 4 is 130. Combine like terms. So I get 2x squared plus 4x plus 4 is 130. Subtract 130 from both sides of my equation. And so I get 2x squared plus 4x minus 126 is 0. Divide by 2. So I get x squared plus 2x minus 63 is 0. Let's try to factor. This is a monic quadratic, so let me try to factor this. Bring down the x plus, bring down the positive times negative is negative. I want two whole numbers whose product is 63 and whose difference is 2, 9, and 7. Set each factor equal to 0. X plus 9 equals 0. X minus 7 equals 0. Solve for x. Subtract 9. Add 7. So x equal negative 9. X equals 7. Well, I want positive, and so since I want that it's a positive odd integer, I get rid of negative 9. And so 7 is an integer. The next consecutive integer is 9. So the consecutive integers are, 7 and 9. Those are two consecutive odd integers, positive odd integers, the sum of whose squares is 130. Let me do problem number, let's say 70. How about 70? Let me do problem number 70. Problem 70. The product of John's age in years 5 years ago and his age 9 years ago is 15. Find his present age. So let x be his present age. So the present age of John. Then his age 5 years ago, well, he was 5 years younger. His age 9 years ago is, well, that. And their product is 15. So let's try to solve that. Let's multiply this out. So x squared minus 9x minus 5x plus 45 is equal to 15. Subtract 15 from both sides of my equation. So you get x squared minus 9x minus 5x is minus 14x. 45 minus 15 is 30 equals 0. Can I do that? Let's see. 10 and 3, 5, 6, 15, 2. I don't think I can do that. Okay, so I don't think I can factor this. So why don't I use the quadratic formula? So let me do the quadratic. Let me use the quadratic formula. X equal negative b plus or minus the square root of b squared minus 4ac all over 2a. And so x equal negative b plus or minus the square root of b squared minus 4ac all over 2, a. So x is equal to – 14 plus or minus the square root of 14 squared, 196. Negative 1 times 4, negative 4 times 1 times 30, negative 120 over 2. And so x is equal to 14 plus or minus the square root of 76 over 2. Um, Let me write 76 as the product of 4 and 19, the product of a perfect square. And so 4 is the largest perfect square factor of 76. So x is equal to 14 plus or minus the square root of 4 is 2. Let me factor out a 2 for the numerator. So 2, 7 plus or minus rad 19 over 2. The 2's cancel. So I have here x is equal to 7 plus or minus the square root of 19. Oh, and that's it. I factored out everything. So it's equal to 7 plus or minus rad 19. And so I have two solutions to this quadratic. So his present age is, wait 1 second. This is a word problem. And so 9 years ago, well, 7 minus rad 19 will actually be a negative number 9 years ago. So we don't want negative ages. And so he has to be at least 9 years old. Since he has to be at least 9 years old, then his age, so John's present age, is 7 plus the square root of 19. Because 9 years ago, you do not want him to have a negative age. And so, by assumption, since we're giving an age both 5 years ago and 9 years ago, that we want both of those ages. 5 years ago, he would also been at a negative age, so we don't want negative ages. Okay, so let me do problem number 78. From each corner of a square piece of aluminum sheet, a square piece of size 16 centimeters is cut out. So I have this square piece of aluminum sheet. I'm going to cut out from each corner a 16 by 16 square centimeter. Okay. The edges are turned up to form a open box. And so you're going to actually turn these up so that you're going to get some sort of box from this. Okay. And so let's call this, oh, and let's see. If the box holds 400 cubic, so this box holds uh, 400 cubic centimeters. Okay. And so that's the volume here of this box. We want to figure out the dimensions of the box. Okay, so let's figure out the dimensions of the box. So let's call it x centimeters, x centimeters. I certainly already know that this height here is 16 centimeters. Okay, and so that means that this is x centimeters, and that this here, oops, went too far, that this is x centimeters. Therefore, this whole length is x plus 32 centimeters. And so that's x centimeters. And this whole length here is again x plus 32 centimeters. Okay. So, not that it's really necessary. I won't put that in. We just know that, but I'm not going to use it, so I guess I won't write it in. So first off, uh, note that the volume of a rectangular parallelepiped is length times width times height. And so I have that the volume, 400, is equal to the length, x, width, x, height, 16. So let me divide both sides of my equation by 16. Then I can solve for x. So I get that x squared equals 25. And so x is equal to, by the square root property, plus or minus the square root of 25, which is 5. But again, since I'm talking about length, I'll only look at the positive quantity. And so the dimensions of my rectangular box is 5 centimeters by 5 centimeters by 16 centimeters. And that is those are the dimensions of my box. Uh, let me do, I guess, maybe one last problem. Let me do problem number 80. An object is thrown from the top of a 1,280 foot tall building with a velocity of 32 feet per second. So you're on the top of a building and you throw some sort of object off your building, which turns out to be the building is 1,280 feet tall, and you drop it with a velocity of 32 feet per second. Okay. The distance s, so this distance here s of the object, t seconds after it has been thrown off the building, is given by the formula 1280 minus 32 t minus 16t squared. After how many seconds will the object hit the ground? Meaning, how long before there is no distance between that object and the ground? And so, since the distance above the ground is measured by s, then I want to figure out what is t when the distance above the ground is 0. So let me do that. And so I want to figure out 1280 minus 32t minus 16t squared. When is that equal to 0? Well, let me divide every term here by negative 16t, negative 16. And so I get, and let me write the t squared first. And so I get t squared plus 2t minus 80 equals 0. I guess I can't factor that. That's 16, 5, 8, 10. 8, 10. Ooh, maybe I can factor that. And so let me factor this monic polynomial, this monic quadratic. Bring down the plus times minus is minus. I want to find two whole numbers whose product is 80 and whose difference is 2, 10, and 8. 10 times 8 is 80. 10 minus 8 is 2. Set each factor to 0 and solve for t. Subtract 10. Add 8 to both sides of your equation. And so t equals negative 10. T equals positive 8. Since I'm talking about the time that you threw it off of a building, I don't want time to be negative. So let me get rid of the negative time here. And so the answer is 8 seconds. So it takes 8 seconds for this object to strike the ground. Okay? And that's fairly realistic to drop an object off of a building. The only thing is that usually there's some air resistance, which will cause actually it to have a maximum velocity. So usually it slows down at some velocity. Okay, so that finishes off section 11.3.